Hi, and welcome to 5-Minute Physics. This video is about charge and current in electrical circuits. So, what is charge? Well, electrical charge is a physical property that we can measure and use to describe a particle, a little bit like mass. Unlike mass, it can be either positive or negative. Now we measure charge in coulombs, and note that that's a capital C if you're going to abbreviate it. Lowercase c is wrong. Just to be really awkward, in equations, charge is given the symbol Q. On behalf of physics, I'm sorry, we just like to make things needlessly complicated. Where charge can be positive or negative, remember that a positive charge is not going to behave in the same way as a negative charge. They'll get pushed in different ways in magnetic fields and electric fields that experience different forces. So that's probably the one thing that makes charge a bit more complicated than, for example, mass. Now when we have a moving charge, we call that a current. That's all a current is, just moving or flowing electrical charge. And current is measured in amperes, or amps for short, or a capital A if we're going to go really short. A current of 1 amp means that 1 coulomb is being transferred every single second. Fairly straightforward. There is of course an equation for that, because we love equations in physics, and it looks like this. Charge is current times time, or Q equals IT for short. You could be asked to calculate any one of these things in the exam, so you need to make sure you're happy rearranging this equation. And this is also one of those exams that you need to know by heart for your GCSE. If you haven't learnt it, you're going to be stuck. A couple of things to note here. Time needs to be in seconds, and current needs to be in amps. Sometimes in a question you get given time in minutes or in hours. You might get given current in milliamps. Usually, not always, but usually charge will just be in coulombs. If any of those things are not standard, you're going to need to convert them first, and we'll have a video up on how to do that if you're not sure about that. So let's think about a worked example. An excited and presumably quite incompetent teenager takes 4 minutes to get their new drone to fly 1 lap of the bedroom on Christmas morning. During this time, 5 coulombs of charge pass through the drone's battery. What is the average current flowing? Well, clearly we need our new equation for this. Q equals IT. And if we identify what we've been given in the question, that will help us to work out what we need to do with the equation, whether we need to rearrange it, and whether we need to process that information at all. So we've got time, 4 minutes there. We've got the charge, 5 coulombs, and we want to find the current. So it's worth just jotting down on the side of your exam question or your exercise book what you've been given and what you're missing, like this. And you'll notice that time here has been given to us in minutes, so we need to convert that first of all into seconds. 1 minute is 60 seconds, so 4 minutes times 60 will give us the time in seconds, 240 seconds. Now we want to work out current, but if you look at the equation at the moment, then current is on the same side as time, so we need to rearrange the equation, and to do that we are going to divide both sides by time, if we're speaking mathematically correctly, or you could say we're going to move time across, and because time is multiplying on the right hand side, it's going to divide when we move it across to the left. So there we go, current is charge divided by time. So if we get our numbers from the question and we substitute those into the equation, we're going to have 5 coulombs divided by 240 seconds to give us our current. So our current would come out as 0.0208 amps. Now that's the number you'd read off your calculator, but just be aware that sometimes you have to give your answer to the correct number of significant figures. One way of doing that is to look at what you've been given in the question. Now in our question, our information 240 seconds, that's to 2 significant figures, 5.0 coulombs, that is actually also to 2 significant figures, so we're going to give our final answer to 2 sig figs as well, so 0.021 amps. Now, a common misconception is that the battery or the power supply supplies the charge, it provides the charge that flows around a circuit. But circuits use metal wires, and metal, as you might have learnt in chemistry, is made of a lattice of positive ions with free electrons that can move around in between them. Those free electrons are the charge which moves in an electrical circuit. So the charge is already in the wire, it doesn't come from the battery or from the power supply. So what does the battery do then? Well, it acts as what we call a source of potential difference. It supplies energy to the charge, making it flow, and provided there is a complete circuit with no gaps, then we have a current flowing around our circuit. Now notice that in this type of circuit, this is a series circuit because everything's connected one after the other, and there's only one option, one route that the current can take. In a series circuit, the current is the same wherever you measure it. We could say this is a closed loop. There's no option for the current to travel a different route. So if it's 0.5 amps on the right, it's going to be 0.5 amps on the left. And all the components are going to have 0.5 amps flowing through them. That's a really important idea when it comes to circuit calculations. So that's about as simple as a circuit can be, isn't it? But if we have a slightly more complicated circuit, a parallel circuit like this, we can see that the charge has now got a couple of options. It could flow through the top loop, or it could flow through the bottom loop. Now, if we start off with our 0.5 amps again, just to stick with that, make life simple, that 0.5 amps is going to split up. Some of the current is going to go through the top loop, and some is going to go through the bottom one. Now, assuming those two light bulbs are the same and have the same resistance, then the current is going to split evenly. So we'd get 0.25 amps through the top one and 0.25 through the bottom one. And then, at the end, they're going to recombine, and we're going to get 0.5 amps through that last ammeter. So we can see from this that we've got two loops in this circuit, the green loop there and the orange loop. Now we've got to be a little bit careful here because the current is only the same around a closed loop, and neither of these loops is closed. The green loop has a junction with the orange one, and the orange one has the green loop splitting off it. So these are both open loops. So the current is not going to be the same around either of these. Hence it goes from 0.5, drops down to 0.25, and then when the last bit of current rejoins, jumps back up to 0.5. Hopefully that makes sense. So to summarise, an electric current is just a flow of electrical charge. We can work out the size of that current by dividing the charge transferred by the time taken in seconds. Inside a loop, current flows if there's a source of potential difference. That could be a cell, a battery, a power supply, or something like a solar cell. And finally, current inside a closed loop is the same wherever we measure it. Thanks for watching this 5-minute physics video. Please subscribe or check out our other videos explaining GCSE physics in simple 5-minute lessons. Bye for now.